Okay, guys, this is video 3 for section 5.4. Here we're going to solve rational inequalities. Rational inequalities, so technically your function, it's been represented using fraction. Okay, so I will go over the example from the textbook. So first, okay, the example 1, solve rational inequality. By graphing. So that will be super nice if we will be able to use graphing calculators. Okay, but we have rational inequality x minus 1 over x squared minus 4. It's greater or equal to 0. Okay, so on the left side, we have rational function. So we have a function f of x, it's equal x minus 1 over x squared minus 4. So rational function, you have polynomial divided by polynomial. And again, you're going to see the fraction. So if we'll be able to use the TI-84, I'm going to show you, by the way, how the graph of this function looks like. But what you will do first you will graph f of x equal x minus 1 over x squared minus 4. Okay, so the graph of this function, and I'd like to explain it first that way, so like with polynomial inequality, so we understand what we're solving. So this function has a point 0, 1, 4. This is 1 over 4. Okay, by here. Then we have a point 1 comma 0. So this is 1. This is 2. Negative 2. We have vertical asymptote. And when x is equal to, we also have vertical asymptote. Vertical asymptote means the graph approach vertical line, but it will never intersect. And there's one extra point, 3.4. 4 over 10, which will be 2 over 5. We have a point right here. Again, I'm just going to sketch the graph. Let's put it in purple. Okay. Then we have a graph which looks like this. And then there's a point somewhere here. So I just sketched the graph. So in purple. So rational functions, like you see, they're not continuous. Okay, the domain is also restricted. Okay, so that's for rational function. You guys, we will spend a lot of time on learning them. Now we're talking about solving rational inequalities. So going back to our inequality, the inequality which we need to solve was x minus 1, which we just graphed this function, divided by x squared minus 4 greater or equal to 0. So technically, to solve that, we're looking for x values for which y values are greater or equal to 0. So to solve it, we are looking for x values for which function value, for which means for which y values. Okay, just so I don't know why I put the parenthesis. For which y values are positive or equal to 0. Okay, right here, greater equals 0. So now I will go back to the graph, just mark that in yellow, and I'm going to mark in yellow the positive y values. So which means I'm going to mark in yellow the part of the function which is above x-axis. This one right here, greater or equals 0, and this one. Okay, so what will be the solution of this inequality? Okay, so this function has positive y values for the x from the interval, hopefully you guys see it right here, from -2 to 1. And I'm going to include 1 because this is not strict inequality. We have x minus 1 divided by x squared minus 4 greater or equal to 0. That means we're going to include x-intercepts. Okay, so that will be bracket. And there's another interval. Also, this function has positive y values for x's from 2 to positive infinity. Union 2 to positive infinity. Again, 2, it's a vertical asymptote. That means the graph it's approaching x equal 2, but it will never intersect. Okay, so that's the solution of this rational inequality. Much easier to read the solution from the graph. I'm going to teach you how to solve rational inequalities algebraically. So next, solving rational inequalities algebraically. Which means without graph. So this is what we're doing next. Okay, so example, solve algebraically. And we have 3x squared plus 13x plus 9 divided by x plus 2 to a second power less than or equal to 3. So step 1 of solving rational inequalities, you always want to have a 0 on the right side. Okay, so step 1 will be rewrite the inequality to have 0 on the right side. So we always need to do that. So in this case, we're going to subtract 3 from both sides. Okay, so in our case, we're subtracting 3 from both sides. Okay, so our inequality will be 3x squared plus 13x plus 9 over x plus 2 to a second power minus 3 less than equals 0. Okay, so that was step 1. So step 2 will be, you have to simplify. Simplify the left side by getting common denominator. So the idea is, when you're solving rational inequalities, that you have only a fraction. So again, one expression and the second expression, and only in inequality and a 0 on the right side. So this is what we're trying to get. Okay, so we need to get common denominator. So let's work with the left side. Our left side is 3x squared plus 13x plus 9. So again, I'm at this moment only will be working with left side, trying to get the common denominator. Divide by x plus 2 to a second power, and then you have minus 3, which you can put 3 over 1. So the common denominator, again, to get common denominator, you may think a little bit like cross multiplication. Okay, our common denominator okay, so you always comparing, checking what denominator you have. We have x plus 2 to a second power and 1. So when you multiply them together, so common denominator will be x plus 2 to a second power times 1, which is just x plus 2 to a second power. Don't FOIL, don't distribute that, just leave it that way. This is our common denominator. So to get the common denominator, again, you may think a little bit like cross multiplication. The first fraction numerator, you multiply by 1. So we'll have 3x squared plus 13x plus 9 times 1, which is the same thing. Copy your denominator, which is x plus 2 to a second power minus 3. And again, the numerator of the second fraction, you're going to multiply by the denominator of the first fraction. So you have 3 times x plus 2 to a second power. And of course, we're trying to build a common denominator. So on the bottom, you have x plus 2 to a second power, which is common denominator. Okay, so still working with the left side. We'll take care of the right side in a second. We're going to simplify that. So since we have a common denominator, rewrite as a one fraction. So we're going to have 3x squared plus 13x plus 9. Again, rewrite as a single fraction. So we keep one common denominator and we combining our numerators. So 3x squared plus 13x plus 9 minus 3 times x plus 2 to a second power. And we simplify in the left side. Okay, denominator, it's perfect. Don't FOIL, don't do anything. Here on the top, you need to distribute. You need to simplify here. We're trying to combine like terms. It's way too many variables, too messy. So let's work with this. 3x squared plus 13x plus 9 minus 3. Think about the order of operation, exponent first. So first what you're going to do, you have x plus 2 to a second power, which means x plus 2 times x plus 2. Divide by x plus 2 to a second power. So first what we're going to do, we're going to FOIL here. Okay, so next 3x squared plus 13x plus 9 minus 3. I open the parenthesis and I'm FOIL. X plus 2 times x plus 2. When you FOIL, you will end up with x times x, which is x squared, x times 2, which is 2x, 2 times x, which is 2x, 2 times 2, which is 4. And copy our common denominator. Okay. Okay, let's simplify the parenthesis. So you have 3x squared plus 13x plus 9 minus 3 times. When you combine like terms in the parentheses, you're getting x squared plus 4x plus 4. And everything over x plus 2 to a second power. Still need to simplify. So next, I'm going to distribute 3 to each. So we have 3x squared plus 13x plus 9 minus 3x squared minus 12x minus 12. Everything over x plus 2 to a second power. Okay, I know it's a long process, but we're almost there. Now let's start simplifying. Okay, positive 3x squared, negative 3x squared, cancel. Okay, we're combining like terms. So you have 13x minus 12x. That will give us x. And then we have positive 9 minus 12. That will give us negative 3. And that's it. Oops. X minus 3 over x plus 2 to a second power. That's it. There's nothing else what we can simplify. So now I'm going back to the original problem. Don't forget that we solve inequality. So we simplify it. Now we're solving this. Our inequality has to be less than or equal to 0. So we are on this step right here. So when I simplify, when I got that common denominator, I simplify this rational expression. Now we're solving this, less than equal 0. Okay, now we're ready. So that was step 2, simplify. Now we're ready for step 3. Step 3, find X-intercepts. X-intercepts, we call them zeros of function. And you're going to find X-intercepts by making numerator equal to 0. Okay. So step 3, find X-intercept. So we have our numerator, it's x minus 3. So we have x minus 3, make it equal 0. We're getting that x is equal 3. Let's save that because we're going to do the same thing what we did with polynomials. We're going to have a number line and our x-intercepts will divide the number line into intervals. And we're going to check which interval satisfies the inequality. So a couple things about the x-intercepts. Since our inequality is less than or equal to 0, since our inequality has a sign less than or equal 0, so because of equal, x equal 3 will be a part of the solution. What that means, for x equal 3, your circle, when we'll graph it, you're going to keep your circle close. So that was step 3. Step 4. Okay, next what you're going to do, you're going to find the x values for which the inequality is undefined. So our inequality is x minus 3 divided by x plus 2 to a second power less than equals 0. And find the x values for which inequality is undefined. How you going to do it? To find them, again I'm here, make denominator equal to 0. We know that we can never ever divide by 0. So to find the undefined, the values for which this inequality is undefined, I'm doing something what I'm not supposed to. I'm making my denominator equal 0. So in our case, denominator is x plus 2 to a second power equals 0. Okay, so what you can do to not have a second power, you can just take the square root of both sides and the second power and square root undo each other, and you end up with x plus 2 equals 0, which means x is equal to negative 2. So for x equal negative 2, this inequality is undefined, so we won't be able to graph it. So since we're talking about undefined values, when we're going to finally start writing down the final solution, which are intervals, you always will keep the circle open. Okay, so note for undefined values, always keep open circle. Okay, because x equal negative 2 can't be a solution, one of many solutions. Okay, which means if we're talking about interval, it's going to be open parenthesis. Okay, so now we have it. That was step 4. Step 5. Create a number line and use the X-intercept and the undefined value to break the number line into intervals. Okay, so what we're going to do, don't forget that you're solving rational inequalities. So rational inequalities, that's in terms of x values. On the left side you have negative infinity, on the right side you have positive infinity. Now our x-intercept was 3, x equal 3. Okay, so on the number line I'm putting x equal 3, and I mentioned that x equal 3 will be part of the solution because we're solving the inequality which is less than or equal. Okay, now the undefined value was x equal negative 2. since this is undefined, so that undefined value will never be part of the solution. And now the number line was divided into 3 intervals. Let me just extend a little bit on this side. Okay, so here it's negative infinity. Okay, so what will be the solution? Let me just copy our inequality. So the inequality which we're solving is x minus 3. This is what we're solving, x minus 3 over x plus 2 square. It's less than or equal 0. Okay, so again, that's the possibilities. The solution can be interval from negative infinity to negative 2. Okay, here. Or interval from negative 2 to 3, since we're including 3, so you have bracket, or from 3 to positive infinity. So to be able to know which interval or which intervals are the solution, we need to do the test. So that will be your last step. Step 5. Do the test. Pick a value from each interval. Substitute for x from the inequality, and don't go back to original inequality, just work with the one which we simplify, which is x minus 3 over x plus 2 to a second power less than equal 0. So do the test, pick a value from each interval, substitute for x from the inequality, and check if the inequality is true. Okay, if yes, of course, that interval will be the solution. So we're going to do the test. Okay, here, let me work with the first interval. So I'm going to pick the x from negative infinity to negative 3. So here I will pick x equal negative 3, and I'm going to replace x from inequality with negative 3. So we have negative 3 minus 3 over negative 3 plus 2 to a second power, and I'm checking if I will get something what is less or equal to 0. Again, don't forget that I'm substitute them right here. Okay, so we're getting negative 3 minus 3, that's just negative 6. On the bottom, you're getting negative 1 to a second power, which is 1. And you're checking if this is less than 0. You're getting negative 6. It's definitely less than 0, so this is true. So the interval from negative infinity to negative 2, yes. So this is our solution, okay? Don't stop here. You need to do the same type of work 2 more times. Next, I'm checking if the interval from negative 2 to 3 is also the solution. So I'm going to do similar work. I'm going to pick x from that interval, so negative 2, 3. Let's just select easy one, make x equal 0, substitute into your inequality. So you're getting 0 minus 3 over 0 plus 2 to a second power, and I'm checking if I'm getting something negative. So I'm getting negative 3 over 2 to the second power, which is 4, less than equal 0. This is definitely true. So yes, the interval from negative 2 to 3 it's also the solution of that inequality. We're getting negative values, which is perfect. And I will do my work one more time. Here, in the last interval, I'm going to pick any x value from 3 to positive infinity. So let's pick x equal 4. So then we're getting 4 minus 3. Divide by 4 plus 2 to a second power, and you're checking if that will give you negative. So we're getting 1 over 4 plus 2 is 6 to a second power over 36 less than equals 0. No, this is not true. Since no, that means the interval from 3 to infinity, not solution. And now we're going to write down the final answer. So final answer. The solution of this rational inequality is the interval from negative infinity to negative 2 union negative 2 to 3 bracket. So we're having negative infinity to negative 2 union negative 2 to 3 bracket. So that's it. This is video 3. I will record one extra video with 2 more examples of solving rational inequalities. Thank you for watching.